Hello everyone. In this video, we shall try and solve this problem. We have a hollow steel tube with an inside diameter of 150 mm must carry a tensile load of 300 kN. Determine the smallest possible outside diameter of the tube if the stress is limited to 100 meganewton per square meter. Now let's try and solve the problem. Okay. Now let's start. Notice there's no made mention of its bearing stress. It's a tensile stress, compressive stress, shear stress, normal stress. No mention of it of any kind. Instead, it simply states that it needs the outside diameter given an inside diameter, a load, and a limiting stress. Now, it is safe to assume that this stress will be the limiting factor or the amount to be applied to the area, which is the area of the hollow steel tube. Now, which area? Since we are given with the inside diameter and we are asked of the outside diameter, then it will be safe to assume that the area to be applied with the stress is the cross-sectional area. So, since this is a hollow steel tube, then we will have this one. The hollow is the inside circle, and this shaded part is the part where the stress will be applied. Now, what do we do with these types of problem? Then what we do is we simply use the simple formula of stress, which is the stress is equal to load over area. Okay? Stress is equal to load over area, where the stress is now the 100 meganewton per square meter. This is 100 meganewton per square meter. While the P is your 300 kilonewton. 300 kilonewton all over the area. So we'll have an area of cross multiply. This would now be 300. I'll convert this K into its numerical value. So this will become 300,000 Newton. Now we have meganewton. Notice that Newton over meter, no? Newton over meter squared, that is Pascal. So M times Newton over meter squared. So I will change M over Newton meter squared into Pascal. So that is Pascal. Now this is now your Newton per meter squared. Simply copy M. We now have 100 MPa. And we know that 100 MPa is simply equal to Newton per mm squared. So I repeat, MPa is simply equal to Newton per mm squared. So that we will have a Newton, and we'll have the mm squared. So that our resulting answer for the area is in mm squared. So let's try and solve. This is 300,000 divided by 100. So we'll have 3,000. That is 3,000 mm squared. Now, why did I have it in mm squared? Because the given inside diameter is in terms of mm. So it will be easier that way. Now, I repeat, the stress will be applied on the shaded area. So the center up to the, or let's blow up. Now let's have this blown up. Okay. From the center to this part, that is your inside diameter, while for this part, that is your outside diameter. Okay, from the center to the inner part, that is your inside diameter. Center to the outer part, that is your outside diameter. Now we are given with the inside diameter of 150 mm. Now we need the area of the shaded area. Now this shaded area is actually the 300 mm squared. What we need is the outside diameter. So I repeat, we have the inside diameter. We also have the area of the shaded part. This is equal to 300 mm squared. What we do not have is the outside diameter. Notice that if I solve the area of the outside using the outside diameter, that is the total area. Okay? If I also use the inside diameter and solve its area, I'll also get the smaller circle. If I subtract the bigger circle with the small circle, I will get the shaded area. So we will get here the total area, okay, or no, the area of the shaded part, okay. The area of the shaded part is simply equal to the area of the bigger circle minus the area of the smaller, area of the bigger circle minus area of the smaller circle. The area of the shaded part, that is 300 mm squared, where the area of the bigger circle is now pi over 4 if we use diameter. So we have the outside diameter squared minus pi over 4 times the inside diameter is 150 mm. So we go with 150 mm squared. Okay, this is mm. 300 mm squared, the shaded area. So the bigger circle minus the smaller circle, you will get the shaded area. Okay, if you notice in this equation, there's only one unknown. This is the outside diameter. Okay, let's try and solve. Pi over 4 outside diameter squared is equal to 300 minus pi over 4, 150. Okay, so let's try. We have it here, 300 minus shift pi over 4 times 150. Okay, we have 182. So to obtain the outside diameter, we simply transpose the pi over 4. This becomes 4 over pi times 182.19 square root. Okay, we transpose the pi over 4 to the other side, and then to remove the squared, we square root. So we'll multiply this first with times 4 over shift pi. Then we do a square root. Then we now have our outside diameter of 15.23 mm. Okay, we now have our outside diameter.